All right, so a couple of examples from section 1.3 in your book. First one is a word problem that has two unknown quantities. So the way this is worded, it says two ladders. If two ladders are placed end to end, their combined height is 31.5 feet. One ladder is 6.5 feet shorter than the other ladder. What are the heights of the two ladders? So first thing, label your unknowns, right? The question is, what is the height of the two ladders? We know one is taller than the other. So give one letter to the taller ladder, and one letter to the shorter ladder. Right? And then use the given information to form equations involving those variables. So the first sentence says their combined height is 31.5 feet. So we can form an equation that says x plus y equals 31.5 feet. There's one equation. Well, we have two unknowns, so we still can't come up with the answer, but the next sentence allows us to form a second equation. It says one ladder is 6.5 feet shorter than the other ladder. Okay, well, I've already decided which one is taller and which one is shorter. So the shorter ladder, y, is 6.5 feet shorter than the taller ladder. Right? So basically I have two equations with two unknowns. Now, my goal here is to form one equation with one unknown. And so I can do that by using this expression for y in this equation. Right? I know that y equals this, so I can put this in for y here, and then I'm only going to have one unknown in the equation. So I'm going to plug in the y value into equation 1. I'll call this equation 1. Okay. So now instead of x plus y equals 31.5, I'm going to have x plus x minus 6.5, which is y, equals 31.5. Now I just have one equation with one unknown. So hopefully this is not too difficult to solve. We add x plus x to get 2x. We're adding a negative 6.5. And we're setting that equal to 31.5. And then we're isolating the term with the x, so we're going to add 6.5 to both sides of this equation. If I add 6.5 to this side, I'm left with 2x. If I add 6.5 to this side, I'm left with 38. Last step to solve for x, we divide by 2, and we get the height of the taller ladder, our x value, height of the taller ladder. Now I can come back here and plug into the second equation, which I've called equation 2, to find y. I know y equals x minus 6.5, so y equals 19 minus 6.5, or 12.5 feet. So that's my y, the shorter ladder. This is my x, the taller ladder. Those are my answers to the question. And then, of course, check it to make sure it makes sense. Do they add up to 31.5? Yes. Is one 6.5 feet shorter than the other? Yes. So you know you did the problem right. All right, and that's always the case with these word problems. You're given enough information to eventually form one equation with one unknown, solve for that one unknown, and then go back and solve for any remaining unknowns. Okay, so let's look at another word problem. This is number 6 in your book. It has to do with the number of basketball games played in a league. It says the basketball league consists of 12 teams, and 12 teams play every other team twice. And the question is, what are the total number of games in the league? Total number of games played. by all teams. Total. Okay, total, whole league. Right, well, if there's 12 teams and they play every other team twice, then each team is playing the 11 other teams twice, right? So each team, kind of got to logic your way through it, right? Each team plays 11 other teams twice, right? So each team plays 11 times 2 games, or 22 games. So each team plays 22 games. Well, there's 12 teams, right? So 22 games times 12 is going to give us 220 and 44, 264 games. Is that right? 22 times 10 would be 220, and then another 44, so 264 games. But you have to remember each game involves 2 teams, right? So both teams are counting that as a game. So you got to divide this number by 2, right? Each game involves 2 teams. So you're going to divide that number by 2 and get the total of 132 games played. And that's going to be your answer. All right? Each team, 12 teams, plays the other 11 teams twice. Each team plays 22 games. 22 games, 12 teams, 264. Each game involves 2 teams, so you divide it by 2, and you get 132 games. All right, let's do one more. And this involves adding a string of numbers, any string of numbers, from 1 to any number. You can add these using this formula. All right, so the story is, well, we won't get into that, we don't have time. But the idea is, let's say we're adding the numbers 1 to 10. All right, so that would be 1 plus 2 plus 3, 4, 5, 7, 8, 9, and 10. Now, if you reverse it and say 1, 2, 3, 4, 5, 7, 8, 9, 10, you're going to notice that if you add each row here, you're going to get 11, right? 2 plus 9, 3 plus 8, so forth. 11 all the way through, right? 11, 11, 11, 11, 11, 11, 11. So that's where this formula comes from. When you're adding the numbers from 1 to n, if you add that twice, you're going to get 1 more than that n value, right? So you're going to be adding up 1 more than the n value n times, but that's going to be the sum of, that's going to be twice what you're looking for. So that's where the dividing by 2 comes in, right? So 1 to 10 would be, our n is 10, right? So we get 10 times 11, that's where these are, 10 11s, but that's the sum twice. So we divide by 2. And now we have a formula to add any numbers from 1 to any number n. So let's just look at a couple examples where it'd be too much to actually write it out. Let's say if we let n equal 27. All right, so what is the sum from 1 to 27? Question, sum of numbers from 1 to 27. So here n is 27, so our sum is going to be 27 times 28 over 2. And you plug that into your calculator, and you see your answer is going to be 27 times 28 divided by 2, and it's going to be 378. All right, so you can add up any, I got turned off there for a second, but sum of any list from 1 to n, use that formula, and you get your sum.